In the previous video, we learned how to differentiate by the chain rule using the long method. And that involved identifying the inside function, then differentiating it, then differentiating the outside function, and then multiplying them both. That was the long method. Now, in order to speed up that process, we're going to be doing some examples of the short method. I have 6 examples over here, and I need to differentiate each of these using the short method of the chain rule. The short method says that dy upon dx is equal to the derivative of the outside function, leaving the inside function alone, times the derivative of the inside function. And this is exactly the same as the chain rule. This was the derivative of the outside function, and this was the derivative of the inside function. So here we're going to learn how to use the chain rule directly without identifying u. Let's look at the first example. This first example is exactly the same as of the previous video. The rest examples are changed. So in this first example, I have y is equal to 2x plus 6 whole raised to the power of 12. This is the inside function and this whole is the outside function. First, I need to take the derivative of the outside function, leaving the inside function alone. So to take the derivative of the outside function, I'm going to use the power rule and bring this power 12 down. So dy upon dx would be equal to 12 times the inside function is left alone, so 2x plus 6 as it is, and the power 12 gets reduced by 1. This was the derivative of the outside function. And now I need to multiply this with the derivative of the inside function. The inside function is 2x plus 6 and the derivative of this is going to be 2. So I'm going to multiply this by 2. 12 times 2 is 24. So dy upon dx would be equal to 24 times 2x plus 6 whole raised to the power of 11. And so this is my answer to the first question. In the next example, I have y is equal to 2 minus x whole raised to the power of 6. In order to differentiate this, 6 would come down, so dy upon dx would be equal to 6 times, and the inside function is left alone. So 2 minus x, I'm going to write as it is, the power gets reduced by 1, and times the derivative of the inside function. The inside function is this 2 minus x, and the derivative of this is minus 1. So dy upon dx is equal to negative 6 times 2 minus x whole raised to the power of 5. This is the answer to the second question. The third example is y is equal to 5x square minus 6x plus 8 whole raised to the power of 9. First, I am going to take the derivative of the outside function. So dy upon dx would be equal to, the power comes down, so this would be 9 times, and the inside function is left alone. So 5x square minus 6x plus 8, and the power gets reduced by 1, so 9 minus 1, and times the derivative of the inside function. This is the inside function, and the derivative of this is going to be 10x minus 6. 9 minus 1 is 8, so dy upon dx is equal to 9 times 5x square minus 6x plus 8 whole raised to the power of 8 times 10x minus 6. This is the answer to the third question. In the fourth question, I have y is equal to cube root of 6x minus 5. I can rearrange this to write this as 6x minus 5 whole raised to the power of 1 upon 3. This is the inside function and this whole is the outside function. First, I am going to take the derivative of the outside function. So this 1 upon 3 would come down. So dy upon dx would be equal to 1 upon 3 times the inside function is left alone. So 6x minus 5 whole raised to the power of 1 upon 3 minus 1 times the derivative of the inside function, which over here is going to be 6. 6 divided by 3 is 2. So dy upon dx is equal to 2 times 6x minus 5, and 1 upon 3 minus 1 is minus 2 upon 3. In order to make this power positive, I can write dy upon dx is equal to 2 divided by 6x minus 5 whole raised to the power of positive 2 upon 3. This is the answer to the fourth question. In the next example, I have y is equal to 4 upon x plus 2. I can rewrite this as y is equal to 4 times x plus 2 whole raised to the power of minus 1. This is my inside function and this whole is my outside function. First, I am going to take the derivative of the outside function, leaving the inside function alone. So this minus 1 would come down to get multiplied by this 4, and it would be dy upon dx is equal to 4 times negative 1 times the inside function I am going to write as it is. So x plus 2 as it is, but the power gets reduced by 1. So minus 1 minus 1. Now I am going to take the derivative of the inside function. The inside function is this x plus 2. So the derivative of this is going to be 1. And this gives me dy upon dx is equal to negative 4 times x plus 2 whole raised to the power of minus 2. I can rewrite this as dy upon dx is equal to negative 4 divided by x plus 2 whole squared. This is my answer to the fifth question. In the last example, I have y is equal to 2 divided by square root of 3x squared plus x. In order to differentiate this, first I am going to rewrite this by shifting the denominator to the numerator, and that I can write as 2 times 3x squared plus x whole raised to the power of minus 1 upon 2. The power became negative because this denominator shifted to the numerator, and square root we can write as power of 1 upon 2. Here this is my inside function and this is my outside function. First I am going to take the derivative of the outside function. So this is going to be dy upon dx is equal to 2 times negative 1 upon 2. This power came down, and now I'm going to write the inside function as it is. So 3x square plus x, but the power gets subtracted by 1. So minus 1 upon 2 minus 1, and times the derivative of the inside function. The derivative of the inside function is going to be 6x plus 1. 2 divided by 2 is 1. So this is dy upon dx is equal to negative 1 times 3x square plus x, and minus 1 upon 2 minus 1 is minus 3 upon 2 times 6x plus 1. In order to make this power positive, I can shift this term to the denominator. So I can write this as dy upon dx is equal to negative 1 times 6x plus 1 divided by 3x square plus x whole raised to the power of 3 upon 2. This is the answer to the final question.